All right. So now anything you say from this point on is for posterity. So just be warned. So thank you everyone who has joined us so far. I expect that we'll probably get some more latecomers, but I want to thank Jason and Matt for taking the time to put this together for us and talk to us about CO2, without which we wouldn't be able to do what it is that we do. And also, while I have you, and again for posterity, thank you everybody for your participation in the Florida Brewers Guild. Your support is really makes all the things possible. We hope you'll join us at our conference, and as I mentioned before, this will be available on our YouTube channel when we are done today. If you want to go back and check, or if you need to bug out early, that's fine. Please save any questions you have for the end. Either pop them into the chat or hold on, and we will we'll open up the virtual floor for questions at the end. And so with that, I will mute myself and turn things over to Jason and Matt.
Sean, I appreciate everybody taking the time to join us this morning. We are Vitalis. We are an OEM based in Canada, but ship equipment all over the world. We primarily specialize in CO2 handling. We are CO2 handling experts. And today we are going to speak to you all about CO2 independence, what you need to know about CO2 capture and storage systems for breweries. I'm Jason Laronde. I'm sales manager here at Vitalis. I've been here since very, very early on. Shortly after our inception in 2016, I joined the company in 2017. I've had the privilege of working on over 100 CO2 handling projects all over the world, primarily in food and beverage, but also in pharmaceuticals, aerospace, material science applications. And over the last few years, a group of individuals I really enjoy working with, which is those that work in the brewery space. It's just a really fun group to work with. You guys are great. And as you guys all know, and as Sean has alluded to, CO2 is a major part of your business, and that's what we happen to specialize in. So I'm looking forward to speaking to you all today.
Yeah, I also just want to say thanks to Sean and the Guild for inviting us on, and thanks to you all for joining as well. My name is Matt Cameron. I'm an account manager here at Vitalis. My background's a little more of a technical one, having spent the better part of the last 2 decades fabricating, installing, commissioning brewing equipment systems all across North America. Formerly, I was with Newland Systems, and then moved on to Kone Brewing Systems. Little fun fact, I actually helped build and install Brew Hub in Lakeland here in Florida. It's been a great experience for me putting equipment in across North America over the years.
So at Vitalis, we provide clean tech solutions for some really cool markets. Our experience with the beer industry actually goes back several years. It started with helping one of the world's largest hops extractors create specialty CO2 hops concentrates using our equipment. We are a vertically integrated original equipment manufacturer of CO2-based technologies with in-house R&D, design, engineering, production, and support. And our mission is to help producers thrive while becoming more resilient and future-proof. We do that by utilizing the unique properties of carbon dioxide in a number of different ways, like extracting or refining natural ingredients from biomass, or employing CO2 as a heat transfer fluid and a natural refrigerant, or recovering and distilling CO2 for repeated use, which is what we're going to talk to you all about today. We have over 150 installations on 5 continents, and our CO2 expertise is recognized worldwide.
As Sean mentioned, CO2 is a big part of our day-to-day in the brewery, and it's a key part of the operation. Probably something that we all just couldn't live without. So, when we're looking at usage in craft breweries, whether you're packaging, blanketing, purging, we all need CO2 in some shape or form. But we also know that unfortunately, CO2 is not free these days.
So CO2 prices can vary dramatically from region to region, fluctuating with factors such as shipping distances or fuel prices, transportation shortages, and supply disruptions. And sometimes CO2 just isn't available at any price. CO2 prices have actually increased by 58.2% over the last 10 years, outstripping inflation by more than 2.5 times. So these are costs that you can't entirely pass on to your customer, and you need to absorb them as an increasing cost of doing business. We're curious if you want to drop into the chat, actually tell us what your current rate is for buying CO2 by the pound.
Yeah, on top of the cost of CO2, supply origins is something that's nice to know in any food and beverage application where the product that you're making is ultimately being ingested by your customer. It's always really nice to know where that's coming from and how it's being produced, so that your customers can have peace of mind as to what they're putting in their body. So typically, the CO2 you purchase in bulk from your supplier will be derived from things like oil and gas wells, possibly ammonia production for fertilizer, or ethanol production. So ethanol production, okay. Oil and gas wells, maybe not so much. As we've all seen, and we're probably all very familiar with, the production of CO2 from the various sources we just discussed can have some real world negative impacts. Whether it's plant maintenance or plants shutting down entirely, as we've seen in New Zealand. These can all result in supply chain disruptions, higher prices, or possibly even a nice little force majeure letter from your supplier, which is not what we really like to see. One other interesting looming implication is this 45Q tax credit. I'm curious if you guys put in the chat how many of you are familiar with this, but it has the potential to possibly change the landscape quite significantly with CO2 suppliers basically being incentivized to sequester their carbon as opposed to their normal channels of selling it to their customers. So be interested to see how many people are familiar with that and what you guys have heard about the 45Q. So basically, for all these reasons, we've all been frantically looking at ways that we can reduce or optimize our consumption in the brewery day to day, right? Spunding, maybe chaining your tank blowdowns together, scouring the brewery for potential leaks, just to make sure that you're, capitalizing on every kilo or pound of CO2 that you're using. And there's also nitrogen for purging. I know this is a pretty familiar process for a lot of breweries that are looking to knock down their CO2 usage.
So regarding nitrogen, why don't we capture CO2 from the air like we do with nitrogen? Well, this is the makeup of the atmosphere. And the majority of this air is nitrogen, which makes it much easier and more economical to capture, clean, condense, and store for use in your facility. Nitrogen generators aren't new. It's what we use in nitro brews. It is a piece of equipment you can buy, because the vast majority of the atmosphere is nitrogen, there's a lot to get. There's, of course, the oxygen component of the atmosphere, which is what we need to live. Then there's argon, and then there's CO2. And CO2 makes up just 0.04% of the atmosphere. So it just makes economical capture impractical.
Yeah, as Jason mentioned, there's not a lot to go around in the air. So when we look at CO2 produced from fermentation, the numbers are much more favorable. As we all know, there's variables that affect overall production, higher alcohol content, how much you can capture on the front and back end, depending on what system you might be looking at. But either way, it has the potential to really be the great equalizer. The ratio of produced CO2 to consumed CO2 can be as high as 3-to-1 in any given brewery. So I'll let Jason maybe dive into some of the math on this.
Yeah, so the CO2 capture is not a new technology, but often equipment is marketed as to how many barrels a piece of equipment might be appropriate for. So that's how you size equipment. But in actuality, it's more important for you to understand how much CO2 your brewery is actually producing, so that you can select the most appropriate piece of equipment to capture as much CO2 without overbuying or underbuying the capture equipment. So for every mole of ethanol, this is going to get really nerdy into the science, but mole being a unit of measure. For every mole of ethanol produced during fermentation, 1 mole of CO2 is produced. And so we can actually use this formula, which allows us to calculate how much CO2 is actually being produced by each individual brewery. We look at the volume of beer that a brewery is producing per year. We look at an overall ABV of the beer or the beers that brewery is producing. We multiply that by the density of ethanol, and then multiply that by the molar mass of CO2, and divide all of that by the molar mass of ethanol. and we can actually figure out how many kilos, how many pounds of CO2 a brewery will produce every single year. And so if we then plug that into a couple of case study models, we're able to actually show very definitively on or about how much CO2 you realistically could generate. And then when we compare that against what you pay for CO2, how much CO2 your brewery uses every year, we're able to actually figure out what a ROI model might look like when deploying CO2 capture equipment into your particular brewery. In this particular case study, we have a brewery that does 25,000 barrels a year. Their current consumption is about 253,000 pounds. The current rate that they pay now with their suppliers, 55 cents a pound, and their ABV is around 5% when average across all of the brews that they make. So what they then look at a capital cost of equipment of around $175,000 and operating cost of around $500 for utilities and maintenance for that particular piece of equipment. This brewery was able to offset almost 70% of their total CO2 capture to offset CO2 that they otherwise would have had to procure. And so this turned out to be an annual savings of around $90,000 of CO2 they didn't need to buy every single year. And after including the procurement of the equipment and the commissioning, installation, and operation of that equipment, there's actually a break-even period of around 50 months for this brewery. And so over the course of 5 years, this brewery would actually be up around $38,000 over a period of about 5 years. And at that 50-month period, CO2 is effectively free forever for this brewery. Here's another brewery. This is a 60,000 barrel a year brewery. They have a slightly lower consumption at per barrel at 550,000 pounds, and they have a slightly lower rate because they're buying more per year from their supplier at 45 cents. ABV is the same at around 5%. And the break even for this particular brewery is around 18 months, offsetting nearly all of their CO2 procurement to producing nearly all of their CO2 themselves. And then here is a slightly larger brewery at 100,000 barrels with a consumption of 605,000 pounds. Very good rate at 32, so it actually stretches out the ROI to a longer period of time because the rate is so good. But this particular brewery is actually able to offset 100% of their total CO2 consumption with capture alone. Net zeroed their CO2 bill to zero on day one. And are able to break even all of the capital costs to implement the equipment and start capturing their CO2 in just 13 months and have free CO2 and zero to CO2 bill for the entire operation of the brewery ongoing forever.
Yeah, it's really neat to kind of look at these real world case studies and show you that the numbers really do make sense. And I mean, this is something that we've all known about for many years, but we can probably all agree that over the last year, maybe 2 years, it's a conversation that's really become quite popular. We're always hearing more and more when we go to shows or speak with different breweries in the area that, you know, CO2 prices are rising, supply chain issues have been coming up more and more. And so, you know, the conversation of CO2 recovery systems has become quite popular, but it's not new technology. And so, you know, what's the reason that this is starting to become feasible for breweries nowadays, right? Well, until recent years, before, there was kind of those typical barriers to entry, right? The annual production had to be 100,000 or 200,000 barrels. You know, you had to be able to outlay 7-figure capital investments and, you know, be able to allocate space in your brewery that a lot of, you know, mid-size, smaller craft breweries, they just don't have that floor space. I mean, let's face it, we cram as many tanks in and we just do what we need to do, right? And so these were all holding kind of these smaller mid-level craft breweries back from getting this equipment in. You know, there might be dedicated employees that you would have to hire to run this very complex equipment, you know. So there's just all these barriers that basically led to this technology not really being readily available to anyone unless your name was Molson Coors or Anheuser-Busch, right? So, I mean, things have changed a little bit with advancements in technology these days. Manufacturers have been able to overcome a lot of those barriers, right? We're able to develop a system with a more compact footprint. We're able to kind of leverage our supply chain to procure these components that are now being developed at a smaller scale so that we can build these systems that are not these behemoth $2 million systems. So, I mean, all these things have allowed us to develop this technology so that you can bring it into your brewery and have your cellarmen run it. You're not required to put a new addition on the building to put this equipment in, right? So we've been able to develop this system to make it accessible for smaller breweries, right? Lower capacity throughput on the system. It doesn't have to churn at 1,000 kilograms per hour, because it's not realistic for the majority of the market. So it's really refreshing to see some manufacturers out there, putting a lot of work and effort into making this kind of a potential reality for a lot of these breweries out there. I mean, as we all know, the large percentage of the market is this, 5,000 to 25,000 barrels per year. And so it's been really great to see this accessible for the craft brewers. As with anything, when you're looking to purchase equipment, or you're researching and understanding new technology, there's always variables to consider, because it's certainly not a one size fits all solution, right? So, one thing you've got to consider is the volume of beer that you're producing and the amount of CO2 that you're using. As Jason showed in those case studies, it's a very different scenario based on, do you make RTDs? Is my CO2 consumption a lot higher than your average brewery? So it's important to look at the number side of thing. How much beer am I making? How much CO2 am I using? And how much CO2 will I produce from fermentation? All those things kind of go in that equation to work towards, does this make sense for me to implement, right? Sometimes certain breweries will have really great rates with their suppliers for CO2. So, if you're paying 10 cents a pound for whatever reason, let me know if you are, because I'd like to talk to your sales guy. It might not have that same ROI calculation that Jason was showing. So all those variables are really important to look at. And then at the end of the day, that all equates to what ROI might be. But outside of the financial thing, it's also important to consider what the optics of that are on your brand, right? What the value of the impact is on your brand. It's something that everyone's talking more and more about, right? Sustainability, clean technology, and there seems to be a lot of respect in the market for breweries that take a step forward as maybe innovators and look at new technology, and that pays dividends, because your loyal followers and customers are going to respect you for that, and as a result, they'll probably come into your tap rooms more or buy more of your beer. So there's a lot to consider when looking at these systems. Now, that's kind of just considering the idea of CO2 recovery and how that will implicate the brewery, but there's also factors to consider when you actually begin shopping, right? If you've decided to yourself, this technology is the right move for our brewery, there's some more kind of intimate key points to keep in mind while you're doing the research, right? So, I mean, what is the capacity of the system? This is a really important one that we always look at is, if you're brewing 10,000 barrels a year and you've found the system that fits you just right, is that going to be obsolete in 2 years because now all of a sudden, you've maybe moved up to 15,000 or maybe 20,000 barrels. Maybe you had a really great couple of years. You put in a new row of fermenters or two, and all of a sudden your annual volume has maybe doubled. Is that system going to be able to keep up with that capacity of beer? Because it's not great to spend 100,000 or 200,000 on a system and then 2 years go by and all of a sudden it's not really pulling its weight anymore. So the throughput of the system compared to your current volume, but also your projected volume, something very important to consider. Maintenance and consumables, something very easy to overlook. I've got the system, it's operating, I love it, but what filters do I need to replace? Are those filters maybe a proprietary product from the manufacturer? That might equate to not being able to get them when you need them, right? And so now we go back to being limited by supply chain. So, I would say keep a close eye on what those consumables look like and kind of what preventative maintenance looks like, so that you can actually keep the system on and running all the time so it can continue to do what it's designed to do. benefits, I mean, the benefits seem to be fairly obvious. We've all kind of spent a lot of time talking about it. So, you know, let's not beat around the bush. We can probably all agree that, you know, operational cost savings are probably one of the key drivers here. Some of those numbers that Jason flashed up on the case studies were they're pretty appetizing. So, you know, money does make the world go around. But there are other things to consider aside from the bottom line. Cleaner, higher quality CO2 kind of resulting in, you know, a better quality end product for the customers. Better lacing, better head retention are all things that we've seen as a result of using recovered CO2. Supply chain autonomy, you know, not being as dependent on your supplier, whether it's just because of shortages or the price itself. Either way, it's kind of nice to get out from underneath that shadow. And at the end of the day, we go back to the impact on the brand, right? Less environmental impact is always a great feeling and a great look. There always needs to be social proof for people to, you know, adopt new technology, maybe step outside of the comfort zone. It's not easy being the pioneers of new things that not a lot of people are doing. So it has been going on for a long time, right? Big beer's been doing it, but then craft brewers start to get into it, right? We've got Alaska Brewing here that kind of did this more out of a necessity due to their geographical location. You know, when you're when you're living in Alaska and trucking your CO2 all that way and trucking your beer around, it really starts to add up. So these guys are a little bit ahead of the curve. You know, 25 years ago, they jumped down the rabbit hole. But thanks to pioneers like Alaska, you know, this technology is becoming more accessible, but it's also spreading awareness because people can see this. The proof is in the pudding, right? The breweries are doing it. They're seeing the impacts it has on their business model, and it's people are following suit, right?
So how does it work? So first of all, what we start with is the CO2 from your fermentation process. And in many cases, also the CO2 recaptured from blanket gas and purging. We want to capture as much CO2 in your system and recycle it as we can. We then either use a small amount of capacity from the brewery's existing glycol system, or we can couple it with one of Vitalis's R744 CO2-based cool shift heat pumps, if this is part of a new brewery or maybe a broader retrofit. And the recovery CO2 recovery system encompasses these processes here. So the brewery's glycol system, or an optional Vitalis cool shift chiller, provides the cooling for the recovery's onboard heat pump, which cools the cooling heat exchanger. CO2 from your fermentation and other process is plumbed through a foam trap, then passes through the cooling heat exchanger. This cooled CO2 gas is filtered through a series of readily available, low-cost filter media and multiple stages of distillation to remove things like volatiles, contaminants, or other non-condensables. This cleaned CO2 gas is then compressed to a high-pressure CO2 vapor storage vessel with temperature control from heat transfer fluid from the heat pump. This CO2 vapor then passes through another condensing heat exchanger, which condenses that vapor to a high-pressure liquid, which can be pumped to either an existing bulk CO2 storage tank or a tank that Vitalis can provide. And a really great feature of the recovery system is that if you'll remember, in the middle of the process, we store CO2 as a high pressure vapor. What we're doing is actually conserving a huge amount of operational energy to run the equipment for processes in the brewery that only need gas. There's no sense using all the additional energy to condense the CO2 to a liquid, only to then have to boil it back to a gas for processes like purging and blanket gas. This way we can plumb gas processes with gas and liquid to liquid processes with no wasted energy to convert phases twice unnecessarily.
In case you're wondering what this actually looks like, we've got the magic black box here pulled up on the screen now. We provided a little bit of dimensions just so that you can kind of help picture what this might look like in your own facility. This is Recovery 50. It does 50 kilograms per hour. So as you can see, you can distill close to 650,000 pounds of liquid CO2 per year. This equipment can be installed directly in your cellar, possibly in a mechanical room nearby to the cellar, or even outdoors with an enclosure if the space just isn't there inside. If there's an adjacent wall close to the cellar, but it makes sense for this unit to be outside, then that's also a possibility as well. There could even be a scenario where it goes up on a mezzanine in the cellar in case that's kind of how your particular brewery is laid out. Speaking to the purity of the system, most of these systems will get a purity of around 99.99 plus. One key thing is the performance on dissolved oxygen. Yes, it's pure CO2 analytically, but that can be broken down in a myriad of ways, right? And one thing that I've always heard in the brewing industry, I've probably installed and commissioned 500 brew houses over the last 20 years. DO is always kind of creeping around and being a problem. So one of the things that we've focused on is a pure, clean CO2 with low dissolved oxygen. The system should be able to integrate into your existing CO2 network. You shouldn't have to be, running dedicated pipes here, there, and everywhere. As Jason mentioned, we'll tap into the existing glycol system to provide a little bit of cooling for some of the compression processes in there. So it should be, relatively streamlined to put this into your brewery and utilize as much of your existing network as possible.
So, and in addition to CO2 recovery, Vitalis, as we mentioned, we're CO2 handling experts. So we manufacture complete solutions for elsewhere in your brewery. We manufacture R744, which is the refrigeration term for CO2, chiller packages, packaged and custom heat pump racks for large-scale production environments, CO2 and multi-solvent extraction systems for hops extracts and other botanicals, and downstream refinement systems for the post-processing of extracted products. So with that, I'll close with Vitalis Recovery CO2 capture system is the first commercially available CO2 recovery system designed specifically for mid-sized commercial craft breweries that can provide economically viable capture of CO2 to match your rate of production and allow you to approach or achieve CO2 independence. If you have more questions, have considered CO2 recovery, but solutions you've previously explored just didn't make sense, or would like to see how recovery could work for your particular brewery, you can contact myself or our strategic account manager for breweries, Matt Cameron. If you have your phone on you, you can pull up a little QR code. It'll take you right to a web form, and that'll take you straight to Matt's contact information, and he'll get right back to you. Or you can reach out to him directly at matt.cameron@vitaliset.com or 604-418-7060. And with that, we will open the floor to any questions that anybody might have.
Gotta have a shameless plug there at the end, right, Sean?
Of course. So first of all, thank you guys. We've got, where'd it go? All right. Is there a difference between, you can probably read the question yourself. I don't need to read it to you.
Well, why don't you hold the floor for us there?
And you know what? I will read it out loud because anybody who is watching the recording of this probably doesn't see the chat. So the question is there a difference between how much CO2 is produced during fermentation and how much you can actually capture and use?
Great question. Yeah, that's a great question. And we touched on that a little bit in the slide, saying that, the ratio can be quite large, but as I mentioned, as we all know, during a fermentation cycle, there's going to be kind of that front end where the concentration and quality of the CO2 is not quite up there. It might be at 50% with other volatiles and non-condensables. And the same applies to the tail end of fermentation. So yeah, Luke, that's a great question. There is certainly a difference between how much CO2 is produced and how much you can actually capture. We're looking at around capturable CO2 being conservatively 10 pounds, Canada, so freedom units are going to come out, but I was thinking 3 to 5 kilos, so say 10 pounds per barrel of capturable CO2.
Okay.
Sorry,
Any more questions or questions from Sean? Then we can eagerly await your call or your email, and we look forward to working with you.
If you have any questions, you can pop them in the chat or just pipe up. There's just a few of us here, so if you want to speak up, or if not, okay. Well, I will make this available as well as the deck. We'll make available as well, if that's okay with you guys. And we'll put it in the forums. Thank you everybody for coming. And like I said, we'll put this up on the YouTube channel later today. Carla says, great job, Matt and Jason. Thank you. Thank you, Carla.
Thanks, Carla.
So yeah, and one last plug for if you have not gotten your tickets yet for the conference, please do so. Love to see you in a little bit over a week.
Awesome. Thanks for having us, Sean. Much appreciated.
Thank you very much. Appreciate it.
Appreciate it.
Take care, everyone. Have a great weekend.
You too. Bye.
Bye.